Welcome back. Our topic is heat and temperature. We will cover the topic in three parts. When the first two videos are video lectures and the last video will be problem solving. So let's start with the definition of heat and temperature. Heat is a form of energy flowing between two bodies which are in contact when they are at different temperatures. Temperature is a measure of average kinetic energy of each particle of an object. Or better, it's a measure of how hot or cold something is. When you put an object into a liquid at different temperatures, the heat transfer between the objects will start. And after a while, when the energy transfer completed between two bodies, they will have the same temperature. We can also call this one as final temperature. The other one is thermal expansion. We say the object expands when it gets larger without gaining any matter or having any chemical reaction. And we say the object shrinks when it gets smaller without losing any matter. The amount of expansion or contraction depends upon three factors. First, the size of the object, the type of substance it's made of, the temperature change of the substance. Most substances expand when heated and shrink when cooled. Particles inside the substance move faster so that it needs larger volume when you heated them. This is a nice experiment showing the relationship between volume and temperature. When liquid nitrogen with a boiling point of minus 195 Celsius is poured on the balloon, the temperature of the balloon drops suddenly. The volume of the balloon decreases in direct proportion to the temperature. The law describing the relationship between volume and temperature of gases is called Charles' law. I put another fun experiment about the right side of this video. You can watch it by clicking it. Okay, let's continue with measuring temperature. The instrument we use to measure temperature is called thermometer. There are three kinds of temperature scales. The first one, Celsius. The second one is Fahrenheit and the last one is Kelvin. The relationship between them is like this. What I'm going to say now is very important. Thermometers are just the reference point we use. They don't measure different temperatures. They just represent the same temperature with different numbers. You can see the examples about heat and temperature in the final episode. Okay, the other one is measurement of heat. We can measure heat with the device called calorimeter. The unit of heat is joule or calorie. 1 calorie is the amount of heat needed to raise the temperature of 1 gram of pure water by 1 degree Celsius. As you can see on the picture, if we heated 1 gram of water to raise its temperature for 1 Celsius, to achieve this we need 1 calorie or 4.18 joules. Let's continue with heat capacity. Heat capacity or thermal capacity is a physical property of matter, defined as the amount of heat to be supplied to a given mass of a material to produce a unit change in its temperature. It depends upon three things. First, the amount of the substance, type of the substance, and change in temperature. The first one is amount of the substance. When 1 calorie of energy is required to increase the temperature of 1 gram of water by 1 degree Celsius, 2 calories of energy are needed to increase the temperature of 2 grams of water by 1 degree Celsius. The second one is type of the substance. When the energy required to raise the temperature of 1 gram iron is 0.11 calories, it's 0.22 calories for 1 gram of aluminium. The last one is change in temperature. The required energy to raise the temperature of 1 gram water for 7 degrees is 7 calories. The final subject of today is specific heat capacity. Specific heat capacity is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. The relationship between heat and temperature change is usually expressed with this equation. Q is equal to C times M times delta T. Q is the heat, C is specific heat capacity, M is mass, and delta T represents change in temperature. The relationship does not apply if a phase change is encountered, because the heat added or removed during a phase change does not change the temperature. As the name implies, each substance has different specific heat capacity. For example, specific heat capacity of water is 1 calorie divided by gram times Celsius. That because 1 calorie is equal to 4.18 joules, we can also write specific heat of water as 4.18 joule divided by gram times Celsius. That's enough for today. We will meet at the next video. Until that time, take care of yourselves. Bye.